Okay, in today's lesson we're talking about angles and angle relationships. Yesterday we talked about the segment addition postulate that stated if you've got a line segment that the two smaller pieces here, AB and BC, if you added AB together with BC, you would get the total AC. Today, instead of talking about the segment addition postulate, we'll be talking about the angle addition postulate, which is basically the same thing. Okay. Before we do start, reminder that measuring angles, okay, we always measure angles in degrees. And degrees have absolutely nothing to do with how long these legs are. Okay, I could chop them off here and here, the angles are the same size. An angle measures how far that angle opens. Okay, the measurement of an angle is how open the angle is. Such as a door. A closed door has an angle measure of 0 degrees. If you swing it all the way back and it hits the wall, all of a sudden it's got a measure of 180 degrees. Okay, 0 all the way to 180. If the door is sticking straight out from the wall, it's open at 90 degrees. Okay, and it's a measure of how open that line segment or those two rays are. First off, let's talk about what adjacent angles mean. We use this word adjacent a lot in geometry. Adjacent pretty much simply means next to. So if two angles are adjacent to each other, they're pretty much next to each other. Now they do have to share a common vertex. Here angles 1 and 2 are adjacent. And they also have a common ray in the middle. Okay, so these two angles are adjacent. Here, angle 1, 2, and I'm going to go even a step further. If that's angle 3, all three of those angles are adjacent. 1 is adjacent to 3, 1 is adjacent to 2. 2 is adjacent to 3, 2 is adjacent to 1. Because 2 and 1 share a common vertex and they share a common side. 2 and 3 share a common vertex and they share a common side. Examples, non-examples. It says angle 3 and angle ABC are not adjacent. Angle 3, which is this angle here, and angle ABC, the whole angle, are not adjacent angles. Wow, they don't share, well, actually they do share a common side, don't they? They share this common side. But angle 3 is kind of inside of angle ABC. They're not next to each other. Here, angle 3 and angle ABC are not adjacent because they don't have a common vertex. So you see examples of what adjacent angles look like and what adjacent angles don't look like. Okay, angle addition postulate. You already know this. Let's say that you've got, it's kind of like that same open door theory that I was talking about a while ago. Let's say that the door was here, but you opened it 30 degrees. Then you open it another 40 degrees. What the angle addition postulate says is the whole angle is equal to the sum of the two small pieces. If you open 30 degrees and you open it 40 more degrees, then you opened it a total of 70 degrees. The whole is equal to the sum of the parts. It's just like your segment addition postulate. Okay, let's work a problem. It says the measure of angle ABD. ABD is right here. It's 37 degrees. It tells us to measure of angle ABC, which is the whole angle. Which reminders, when you're naming angles, make sure your vertex is in the middle. So if I'm talking about angle ABC, go from A to B to C. That's this angle here, the whole angle. So I'm going to put down here the whole thing. The whole angle is equal to 84 degrees. And what are they going to ask us? This angle. What is the measure of angle DBC? Well, the whole thing's 84. One of the small angles is 37. Abby, use your calculator or your brain, either one. Tell me how big is angle DBC? The whole thing's 84. One small piece of it's 37. What's the other piece of it? Or just tell me how to find it. You just subtract. The whole thing's 84. The small piece is 37. We subtract. We're left with 47 degrees. Good job. Something else I need to point out that we've not discussed this year. Angle DBC has a measurement. Anytime you see that small m in front of an angle, it simply means the measure of that angle. Okay, how big is that angle? ABC, or This is not true. Angle of DBC is not equal to 47 degrees. Okay? It's an angle. It doesn't equal a number. An angle does not equal a number. The measurement, what's that M there? That's fine. The measure of that angle is equal to 47 degrees. So that's all that M means. And of course, we always throw the algebra in afterwards. We show you the basic, the simple, and then we go to algebra. And we make sure that you're able to apply what we just did in an algebraic sense. And just what we need you to know about this is when I add this angle here to this angle here, I get the whole angle. Okay, that's all that you're doing. So with this scenario, it says GFZ. GFZ is 37 degrees. It tells us that ZFE is 2x plus 125. And it tells us the whole thing, GFE, is x plus 163. We need a relationship. And that relationship is that angle addition postulate. Kyle, could you write me an equation using this? This angle is 37, this is 2x plus 125, the whole thing is x plus 163. Wait a minute. I'll start you out. 2x plus 125. That piece. So this will equal the whole angle. This plus the 37 will equal the whole angle. I could read my angle. What you're saying. If I took this angle here, added to this angle, then I have the whole angle. That's what I just wrote. If I take one angle, I add it to the other angle, I get the whole angle. We solve it, plug it back in, we're finished. Now we know what the angle is. Okay. Am I right there? Okay. My bad. Let's try that again. 38 degrees. 38 degrees. Thank you very much. That would have been better. So we want all of our x's on one side. Here's an x, move it over here. Minus x. Mark it out. 38 and 125, let's move it over here by doing minus 38 and minus 125. And I think you actually get 0 when you subtract those. So we get x equals 0. And here's the thing, guys. On all these problems, even if they don't ask you, plug that back in. Because you'll never miss a problem if you'll take that and check it. So if x is 0, well, that's going to be pretty easy to plug in. There you go. That means that the measure of GFZ, and let me come over here and erase all this. If x is 0, that means the measure of GFZ is still 38. That means that ZFE is 2 times 0 is 0 plus 125 is 125. And that the whole thing is 0 plus 163, which is 163. And you check it. 38, 125, does it give you 163? Yes. That is the only x value when plugged in that will make it a true statement. Make it a true scenario. Next one gives you GFN, which is here, is 4x plus 10. It tells you that NFE, which is this angle, is 14x plus 3, and that the whole angle GFE is 157 degrees. Rachel, help me out. What is the relationship here between the three angles? Yeah, the equation. 14x plus 3. Good. The two angles, when you add them together, you get 157. Small piece plus small piece equals whole piece. Okay, the whole equals the sum of the parts. We put our x's together. They're already on the same side, so we're just going to put those together. Anything that's not an x, and here's, again, a shortcut. You've got a 3 and a 10. Pretty much you have 13 that you need to move over there. Why not just go ahead and do minus 13? Put them together, you get 13, so let's subtract 13 on the other side. Gives me a total of 18x equals 144. And somebody that's divided by 18, what did they get? 8. So x should be 8. We can always check it. If x is 8, 14 times 8, because look, it asks for the measure of NFE, it didn't ask for x. They want to know how big is NFE. Well, NFE is not 14x plus 3, it's 14 times 8 plus 3. 112 plus 3, I believe that's 115 degrees. And to go ahead and check it, plug it in everywhere. 4 times 8, 32 plus 10 is 42. If you add 115 and 42, you get 157. Next up, and we're following kind of the same path we did with segment addition. We talk about with segment addition, the whole thing equals this piece plus this piece. And then we talk about midpoints. Well, to an angle, this is a midpoint. An angle bisector. The word bisect we learned the other day. Bisect means to cut something into two equal pieces. So an angle bisector cuts an angle into 2 equal pieces. So anytime you have an angle bisector, which here, BR is an angle bisector. Ignore all this other stuff. We'll talk about it later down the road. BR is an angle bisector, and what that means is this angle, which is PBR, and this angle, which is QBR, are congruent. An angle bisector cuts a bigger angle into 2 smaller congruent angles. There's two different ways that you can show that angles are congruent. You can either do the same number of arcs, 2 arcs here, 2 arcs here, or you can use tick marks. You do an arc with a tick mark on it, you can do it either way to show the 2 angles are congruent. There we go. In the diagram, RQ is an angle bisector. RQ bisects angle PRS. The measure, I wish they hadn't even put this next part. The measure of the 2 congruent angles, they even told you. Okay, it's an angle bisector. Well, that's why it's an angle bisector. They have 2 angles, which is x plus 40 and 3x minus 20. Well, we can't do x plus 40 plus 3x minus 20. We can't use the angle addition postulate because we don't know what the total is. They don't tell us the whole thing is 180 or 150 degrees or something. We don't know. They only tell us that RQ is an angle bisector. So instead of setting it up like that, we have to set it up as x plus 40. What do I put next? Good. 3x minus 20. The 2 angles have to be equal. Because RQ is an angle bisector. Let me solve this, Brianna. What do you want to move? X or 3x? How do you move it? Good. Mark it off. Now what do I move? 40 or 20? Good. How do I move it? Perfect. Mark it out. So now I have 60 equals 2x. So x is anybody? 30. It says solve for x. We're done. Okay, that's the actual answer, but I'd rather you go the next step further. Because right now we're fairly confident with our answer. You can be certain. You can be without a shadow of a doubt that answer is right by simply doing this. If x is 30, 3 times 30 minus 20 is 90 minus 20, that's 70 degrees. And 30 plus 40 is also 70 degrees. And something else you know even more now because you actually know how big that angle PRS is. It's 140 degrees. By the angle addition postulate, the whole angle is 140 degrees. Okay, the angle bisector theorem and the converse of the angle bisector theorem. Your first theorem that we've done. Okay, theorems are a little bit deeper than postulates. Postulates are simply common sense statements. This maybe is a little bit more difficult than common sense. Okay, with a theorem, you'll learn later on, and what's a theorem? A theorem must be proven to be accepted as true. We can't just say it's true just because we have to prove it somehow. And that's what, when we get into proofs, you'll know a little bit more about that. But the angle bisector theorem, and here's all you have to put. Just put the name, and I'll give you a second to copy it down. And let's do it like this. I'm sorry, some of y'all already started copying it down. But let's do a separate, we'll do one of 2 things. If you're going to put it into your notes, put something special, a star or something next to it so that you know this is important. This is a theorem. Or write theorem out next to it. Or you can get you a whole other sheet of paper and just start keeping track of your theorems on it. You can do it either way. But all you need is the name. You don't have to put the example. You need a name and you need the words. And if you want to just draw the diagram, any of that, whatever it takes. But what the angle bisector theorem states, if a point is on the bisector of an angle, then it is equidistant, I guess we need to talk about that word, from the sides of that angle. If a point is on the angle bisector, then it is equidistant, or do we need to talk about that word? Let's use our clues here. Equa. What do y'all think equa means? Equal. Distant. Distance. If something's equidistant, then it's an equal distance from the sides. So let's say, and I'll scroll back up to this second page. You have an angle. You have an angle bisector. If I pick a point on that angle bisector, which side of that angle is it closer to? That makes sense, right? It's kind of common sense. And now, one thing we do have to address, how do you measure distance? If you want to see how tall you are, there you go. You want to see how tall you are, you take a tape measure and you put it right on top of your head. And you measure over here to the ground, right? No? No. Distance, anytime you're measuring something, distance, you have to have perpendicularity. I don't know if that's a word, we'll say it is. With distance, you have to have perpendicularity. What that means is if you're going to measure how tall you are, you put the tape measure on top of your head, you measure straight down to the ground. And we all know that perpendicular lines, we'll talk about it later on in geometry, but we already know this from previous classes. Perpendicular lines are right angle lines. So from the tip of my head straight down to the ground, you're going to have a perpendicular distance. Not from the tip of my head over there to the ground, right? Straight down to the ground, perpendicular. Can't be at an angle. So anytime you're measuring a distance, to measure the distance from here to this line, you measure straight over, a perpendicular distance. Perpendicular distance. So anytime you have an angle bisector, any point on that angle bisector will be the same distance. Okay, if I pick the point up here, measure the distance to here, the distance over to here, it's going to be the same distance from each side of that angle. Okay, now let's look at the other one. It's pretty much the same thing. We'll talk about converses later, actually next chapter. But a converse is pretty much the same thing flipped. It works forwards and backwards. What if a point is equidistant? And let's say that that point is the same distance from here as it is from here, perpendicular distances. If it's the same distance, then it also means that it lies on the angle bisector. If a point is in the interior, which by the way, all interior means is it's in the inside. If a point is in the interior of an angle, it is the same distance and, if a point is on the interior and is the same distance from one side as it is from the other side, then that point must lie on the angle bisector of that angle. So same scenario. Same scenario. Let's say that you're in a room and you're standing, I don't know, let's say right here. And I want to know, am I on the angle bisector? Let's say that I want to know if I looked at where I was at, would I actually be standing on the angle bisector of the corner of the room? But I measure, and I notice that I am 10 feet from this wall, but I'm 12 feet from this wall. Am I on the angle bisector? No, no. If I'm closer to one wall than I am the other wall, let's draw that. Angle 1 or 2, which angle would be smaller? 1. Angle 1 would be smaller. And you could actually, later on, we'll talk about trigonometry, and we could actually use some trigonometry to find out how big those angles work. But if you're 10 feet from one wall, 12 feet from another wall, no, not the same distance. Now, if, and that's what the second part, that's what the converse of this theorem states, if you are the same distance from each wall, if this were a 90-degree angle, then this would be the angle bisector, and you would have a 45 and a 45. Now, it doesn't have to work for just right angles. If you're standing here, and you're 3 foot from here, you're 3 foot from here, then you're standing on the angle bisector. That means that, and that would also be the same. So let's not rack our brain thinking about these problems. These are pretty easy. If a point, notice this is 41 degrees and this is 41 degrees. That means that ZX is an angle bisector. And X is on that angle bisector. If a point lies on the angle bisector, the distance from X to W is 7. Vanessa, how far is it going to be from X to Y? 7. Good job. Done. Find the measure of X, Y. If a point lies on an angle bisector, then that point is the same distance from each side of those points. Now again, very important that they put this. Because had they asked you for the measure of that, we would have no idea. Distance is perpendicular. Next problem. L, well, we don't know if that's an angle bisector or not, but we do know this. The distance from L to M, and that is distance, is the same thing as the distance from L to J. Now, this would be a good opportunity to teach you something about geometry. Never assume that two things that look equal are equal. And with this drawing, never assume that two things that don't look equal are not equal. Sometimes people are bad drawers. Okay? So in geometry, never assume anything from a drawing. If two angles look the same, don't assume they're the same. Unless you have tick marks. Those distances are the same. So therefore, L is the same distance from M as it is from J. So Caitlin, since L is the same distance from here as it is from here, it must lie on the, what's this KL have to be called then? Yeah, KL has to be a bisector. Because it's the same distance from here as it is from here. So therefore, if KL is a bisector, if this is 37, then that means that's 37. And that's what you see again. We do the general, then we do the applied algebra part. You're going to be really good at solving equations by the end of geometry, I promise. We notice that, and you can't really see it, but we notice that they tell us that those two angles are the same. They have single arcs on each of them. Those two angles are the same. So therefore, JS is an angle bisector. AS lies on that angle bisector, which means that 3x plus 5, finish it for me, Jordan P. 3x plus 5 would have to
equal 6x.
Perfect.
Now have your
Good job. 3x plus 5 would have to equal 6x minus 7. Hey, let's try to do this one here. Let's try to do the whole equation in our head. I bet you can do it. Think of it like this. Let's move our x's to the right. And in your head, I want you to picture how many x's you have left. We're good there. Focus. Take minus 7, move it to the left. I do plus 7. Okay, 5 and 7. So now we have how many x's we have. We have what it's equal to. How many x's do we have? 3. And what's it equal to? So 3x equals 12. You can finish solving that in your head, right? If 3x equals 12, divide by 3, what is x? 4. So if x is 4, we always plug it in to check. 3 times 4 plus 5 is 17. 24 minus 7 is also 17. So the distances are the same. We want them to be. That's why we said, I want this distance to equal this distance. We found the x value that made that happen. Some more basic definitions. Complementary angles. And you probably had these before, right? You probably had these back in 7th and 8th grade math. Two angles are complementary if their sum is 90 degrees. And here you get a picture of that. And we know from the angle addition postulate, we know what a 90-degree angle looks like. It's the right angle. And we know that if these two angles were adjacent, and they're complementary, that they would form a right angle. 60 and 30 is an example here. So a 60-degree angle and a 30-degree angle are complementary. Now the word complement, I've got down at the bottom. Complementary is an adjective. Complement is a noun. It means the same thing, but it's just two forms of the same word. We'll get our English in today. Complementary describes two angles that add up to 90. If I ask you what is the complement of 60 degrees, that's asking for the measure of the angle. Does that make sense? So there's two ways you could say this. Give the angle that is complementary to 60, or what is the complement of 60 says the exact same thing. So two angles that add up to 90. So therefore, give the complement, notice the noun form, give the complement of the following. Jordan, what's the complement of 20? How do we find it? It has to add up to 90. Subtract it from 90. Good. So 90 minus 20 gives me 70. Good. 20 and 70 is 90. Sierra, what's the complement of 37? Perfect. And Zoe, what's the complement of 45? Has to add up to 90, right? Help her out, Cole. 45. To find complements, all we do is take our 90-degree angle, subtract out what we got, and see what we're left with. So the complement of a 45 would be another 45. Supplementary. Two angles are complementary if they add up to 90. Two angles are supplementary if they add up to 180. A 180-degree angle is a straight angle, a straight line.